Today's lab is Cracker Tectonics. The materials you will need is a piece of paper, graham cracker, a saltine, and a small cup of water. First thing we're going to do is take the graham cracker and break it into 2 squares. Put one off to the side and the other right next to it. We'll move the saltine out for the way, and same with the water. Here we have 2 plates. They can be continental plates, they can be oceanic plates. Either way, we have 2 plates that are right next to each other. Plates move. One type of movement is called divergent movement. Divergent movement is when things move away from each other. Very simply, fingers on top of each of the plates and move them apart. What do you see in between? What movement happened? Divergent plate. Next type of plate movement, we use a saltine and a graham cracker, and we'll put them right next to each other. This is convergent. You have plates which are going to move towards each other. Now these plates obviously are different. One is less dense and one is more dense. We're going to do this a number of times just to see what the average movement is of both of these plates. So we'll just push them very lightly together, finger to finger, and there. Movement. Do it again. Movement. Do it again. Movement. Do it again. Movement. Do it again. Movement. Most of the time, again, these are just examples, most of the time you notice that the saltine goes on top of the graham cracker, or the graham cracker goes under the saltine. Either way. One is less dense. Saltine is less dense, ends up on top. The graham cracker is more dense, it's underneath, it subducts. This is called a convergent plate with 2 different density plates coming towards each other. All right, next type of plate. Let's take this graham cracker, break it into 2 quarters, and put one off to the side. I want you to take this one and break it somewhere in the middle. It doesn't have to be even. And then put it back together. So here are 2 plates, same density, right next to each other. We're going to show a transform boundary movement. This transform fault, or transform movement, is where one plate moves in one direction and the other plate moves in an opposite direction while there is pressure towards each other. So basically, push towards each other, and at the same time, I want you to move one plate up and one plate down, or one plate away from you, one plate towards you. Ready? Go. Okay. Stop. Take a look. What do you notice? What happened? This is called a transform plate boundary. All right. Last one. Here we'll need our water. Take a cracker. Break it into 2 rectangles. I'll describe this first before we do it. You're going to dunk both of these into the water all the way down and hold it for 5 seconds. Then take it out, put it on the plate so that the wet ends are angled towards each other. One more time. Down, 1, 2, 3, 4, 5, on the paper, wet ends towards each other. Here we go. 1, 2, 3, 4, 5, down. These are 2 plates of the same density. We're going to simulate a convergent plate boundary of similar dense plates. Convergent means they go together. So slowly push these together. And as you do that, you notice something happens very different than when we had the dense plate and the less dense plate, when they moved like that. So here you have equal density plates converging, and here you have different density plates converging. 4 main types of plate boundary movement in the Earth.